Good morning. Today we're going to be looking at some of the basics of Java so we can look at some of the vocab, the structures, and the components, just as a nice little review of some of the things that happen inside a project. So we're starting off with the runner. The runner in Java is the only part that we're using to actually look at how to start a program. So we keep it really simple so we can basically black box and avoid some of the stuff we don't really need to worry about when we're starting a program. And since we're running all these programs directly inside Eclipse, and our programs don't have any need to be have any special commands or anything happen with that, it works really well. So let's look at the first line of code that we have right here. On this, we have our package statement. Remember, a package statement is always going to start every single file in Java. If you don't keep it in the default folder of a project where it's like just the root level of the project, if you actually use any organization or structure to your code, it's going to have a package on there which tells you what folder it's inside of. In this case, it's inside the stupid folder. Inside the stupid folder, there's a controller folder because we're using a model view controller structure to organize our code. As you can see in the navigation sequence right here, we have our controller package and our model package. We use a dot to separate them. And in Java, we always have our package names in lowercase. And since I have my stupid 3 project, it's a nice little sample one we can use to organize our information. We'll go ahead and get out of that. We then have our public class stupid runner. Again, visibility of the class is determined with this first line right here. With public, that means it can be seen externally. And most of our classes generally are going to be public just by default. We explicitly say that it's a class right here. This means it's an instance of an object. Now this object is really boring and basic, it's just the runner, and so again, because it's really simple and stupid, I'm calling it the stupid runner. No big deal. Our runners have exactly one method, and that is public static void main. The public static void main method is the method that the Java compiler and the Java runtime environment look for so they can actually execute this project, so we can actually run the code for this. The public static void main method must have one parameter, that is string square brackets args. These square brackets mean array. We'll explain that another time, but it's basically a way we can actually give information to the program when we start it up. But most of our programs don't have anything with that, so we explicitly ignore that at this point. We have only 2 lines of code to go inside the runner's main method, and so we define an instance of our object, in this case stupid controller, which is the object right here. We call it app, well, because app is what we're making. It's just a really simple app, and we use the equals new stupid controller. So the equal sign right here is the assignment operator. That is how we assign a value to this variable. So app is a variable. Stupid controller is the type of variable we're making. So in Java, we have a type and then a name for a variable. And we're doing a declaration and instantiation in one line with this line right here in line 7. And so because it's a object, the next word after the assignment operator needs to be new. The new keyword says that we're allocating memory for this. We're creating a new instance of this. And then the general rule is that whatever is on the left right here, the type right here, is also the constructor that is called on the right. There are some special circumstances that go along with this other times. We'll look at them another time. But we have a new constructor call, and a constructor call always has parameter lists. In this case, it's an empty parameter list because our stupid controller has no parameters, but we always have parentheses after a constructor call. And in Java, any line of code that is inside the squiggles ends with our great friend, the semicolon. Now, because we've created that instance of the object, we now need to do something. So we create the instance, it just says, boom, here it is. It's offsetting memory, it doesn't do anything. We haven't told it to exist and to run yet. We just said it exists. So in order to tell it to do something, to run, we have a start method. And we say app.start. And so we're now going to take a look at that. So let's go over and let's switch to the stupid controller.java file. Our stupid controller file is an example of another class. As you can see right here, the package is the same package as the runner, stupid.controller, because it resides in the same job space that we're working with. We have to have an import line on here for stupid.model.third_stupid because we're using an instance of something that's in a different package. And so anything that's in a different package has to have an associated import statement so it can be used inside the code. We again have the public constructor, or excuse me, we again have the public class header, so public for visibility externally, class defining it's an instance of an object, and its name, which reflects what it is. It's the stupid controller because this is a stupid project. We're just using this to learn some basic components. So we then have our vertical alignment of squiggles. I like to use vertical alignment so I can easily see where my scope or my visibility of my components are. The first thing I have right here is my declaration section. The declaration section is where I put all the data members or instance variables, or some textbooks call them fields, the things that belong to the instance of this class. In this case, I have a string called text, a third stupid instance called sample, and another third stupid instance called second example. Again, the name of the variable reflects what it is. In this case, my string variable is named text. My third stupid instance right here is called sample. My next third stupid instance is named second example. So again, trying to explain what they are as part of the actual naming convention. So again, we have a visibility issue right here. This visibility set is for private, which means only the stupid controller instance has the ability to see what's inside this. No one else outside of the class in another package, project file, whatever, can see the string text, the third stupid sample, or the third stupid second example. They are private values. And again, I call this the declaration section. I keep it up at the top of my class. Java doesn't care where it is, but I found it's much easier to keep all these variables together and organized so I can have access to them as needed. We then have our constructor. Now notice the constructor has a default visibility of public. It has the same name as the class. This is a rule. So if I have stupid controller with a capital S, capital C, the constructor has to have that same name right here as well. Now this is a default constructor. It has no parameters inside that parenthesis. And so when I call it, I would not supply any parameters to it as well. So and notice that there is not a return type. This indicates that a constructor is not a method. It is a constructor. Its job is to build the data members for the class or instantiate the object. So in this case, I have text, sample, and second example, those three data members that belong to my stupid controller object. And as you can see inside the squiggles of this constructor, the body of the constructor, I say this.text is assigned keyword mashing is annoying. I set this.sample is to be a new third stupid object. So again, I'm using the new keyword because I'm calling the constructor for third stupid in this case, and I'm calling the default constructor. On this one, this.second example, it's another third stupid, but this time I'm using another constructor. I'm using a constructor that takes a string parameter. In this case, it takes the string parameter of Java. So I have created three different data members for this. All three of these data members are objects. We can tell they're objects again because they start with a capital letter. Nice little reminder for that. We can't create objects that start with lowercase. It's bad form, bad code design. We don't want to do that. And so we have them right there. We are using the new keyword for our instantiation of our objects. So we're saying that this.sample is a new third stupid. Anytime we use a custom object, we have to use the keyword new. New is required for all Java constructors to be used. We can't just simply say equals third stupid. As you can see, Eclipse automatically gives us an error. As you can see, this automatically gives us an error. If we hover over the error, we get a nice little message saying that the method third stupid is undefined for type stupid controller. Has a quick fix, create method third stupid. No, don't do this. If you accidentally forget to type the new, make sure you go look at this and say, oh wait, this is a sample, this is a data member, oh it's a third stupid. I need to call the constructor. And so anytime you call a constructor, you have to use the keyword new. Generally what you want to look at is you don't want to automatically read that quick fix. That's not what we want to do when we're writing code. Now, inside our stupid controller, we also have a method called start. Notice this visibility is also public. It has a return type void. That means it executes, it's done, and it doesn't give us anything back. It just runs and it's done. In this case, I'm doing systemout.println to simply just print some text to the screen. In this case, I'm printing text, sample.getTextExample, sample.println sample, and sample.printout second example. Now, as you can see right here, normally we put text inside our println statements, but I'm also simply printing a reference to the object in here. We're going to see what happens when we do that. So now let's go look at our third file that's in this, our third stupid.java. It's in our model package. So again, because it's in our model package, that's reflected right here in the package statement at the top of the file. Again, the package statement must be the first thing we actually write. So again, this class is public. It has a class name of third stupid. We have our declarations section where we define the data members that are going to exist inside this. And we're using a couple different data members in this object. We have a string object data member as well as three primitive data members, int, double, and Boolean, the three major primitives that we'll be using in the course. Now again, when we're making a data member, the name of the data member or the field or the instance variable or the class variable, whichever you want to call it, name of that variable matches what it's expected to do. In this case, it's a string, so it's called a text example. It's an int, it's called a number value. It's a double, so it represents a real number. And then we have a private Boolean does exist. One of the nice things you can do when you're making a Boolean variable is use the prefix is, does, or has, and then the word that reflects best what it's storing. So whether it exists, if it has blueberries, whether or not it is a flag. Think about something that refers to what is actually being measured by that variable and use that as a way to quickly name what's inside that so that when you're reading your code, you can automatically say, oh, that's a Boolean value. We have a default no parameter constructor right here. As you can see, my third stupid default constructor. I initialize my data member because again, that's the job of a constructor, is to initialize the data members. And then I'm using a helper method. Helper methods are a great way to actually condense some of your code or to clean up code so it doesn't take up as much space. In this case, my helper method, called helper method, such as it is, goes down right here, and it does something in a minute. We'll take a look and see what happens. I also have my constructor that takes a parameter to initialize a data member, and that's often used inside most constructors where we take a parameter. And as you can see right here, I'm using the this dot prefix. This dot means I'm talking about the current object, aka the third stupid object. I'm talking about this right here. I'm not talking about something else over there. I'm talking about this one right here, the file I'm working with. And so in this case, I have this dot text example equals derp derp derp. But in the constructor that takes a parameter, I set this dot text example is equal to words. Now notice that Eclipse is kind enough to give us the value words right here, and it does a different color highlighting for it. And I can also see that it's going to text example. So I can say that the value of text example, the data member up here at the top of the file, is being assigned from the parameter words. So whatever comes in as a value for that is going to be assigned into this. I then also call the helper method in this constructor. Again, helper methods are often used to help condense out constructors or do work that can be farmed out to another place, making code either easier to read or better to use. I have a getter and a setter. So right here I have a getter for my get text example. All getters have the same basic approach where it's going to be the return type of the data member, in this case string. It's called text example, so the getter will be called get text example. And it has a single one-line statement, return text example. Really quite easy. We have an example setter for this as well. Again, a setter is almost always public as well because the only time we need to change something externally is with a public method. And in this case, my public void set text example, so it has the prefix set and then the same name as the parameter. And then we notice it has a parameter for this. A setter always has a parameter where it's going to assign the value that is given by the other part of the program. In this case, it's a string text example. Now, even though these two names are the same, notice that the colors are different. Text example right here as a parameter is green, and on the right-hand side of the equal sign, it's also green because the assignment operator is taking the value from the parameter and assigning into this dot text example. If I did not have this dot text example, if I simply said text example equals text example, you can see right here that the green now has all three of those values. We also have right here Eclipse's lovely yellow underline of uselessness. It also gives us a warning right here. This assignment to variable text example has no effect because it's basically just a mirroring it, saying this thing is this thing. Oh yes, I'm pointing to the same thing. So we always want to make sure that we use the this dot prefix. The this dot prefix explicitly says that I'm taking what's in the parameter right here and assigning it to the variable right here, the one that belongs to my class. It's a nice way to visually remind ourselves and mentally prepare ourselves for what's going to happen in the code. We also have the methods for the class. We have in right here a helper method. Again, helper methods are almost always going to be private. Sometimes it'll be void or it'll be a return type method. If it's a void type method, it'll simply just have a series of statements followed by semicolons with nothing returned at the bottom. In this example right here, it's exactly what we're doing. In this case, it has the calculation of this dot number value to be the text examples dot length. So I'm going to take whatever is stored inside text example, whatever string value is in that, and we get the number of characters, and that will be stored in number value. The this dot real number will be math.random times 1, 2, 3, 4, 5, 6. Nice, great way to get a random number. No big deal. And then this dot does exist is going to say if text example contains the text Java. So we're going to use some string methods, length and contains, to see if something's in there to determine how we're going to decide what will be assigned into these three data members: number value, real number, and does exist. We then also have our toString method, and I'm going to comment this whole thing out. So I'm going to use the magic power of command whack to comment this whole thing out so we can see what happens. We can determine what's going to be done by this toString, what actually happens with that. So we'll save this and we'll run it. And so keyboard mashing is annoying. Derp, derp, derp. Stupid model.thirdstupid at and stupid model.thirdstupid at. Oh, what is this? So let's go look back at our stupid controller.java. Oh, I'm printing the text. My keyboard mash is annoying. Okay, that's right here. So we have that right there. And then derp, 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 the sample.getText example, because that's what I said right here with this third stupid. And third stupid with no parameters says derp, derp, derp. But this other thing right here, this print on sample, that gives us this package, stupid.model.thirdstupid. So it has the whole structure of our class right there, the package, and then the class name, and then @ sign and some gobbledygook. That's not very helpful. What we have right here inside third stupid, what we just commented out, that toString method, this toString method prevents the @ gobbledygook that we never want to see. And in fact, we want to make sure that our toString method is always written for anything we put inside our model package or anything we possibly want to debug and find information about. And so my string description right here explains how we do that. Now it should be describing the object. It should be created for all classes that are in the *.model package. So whatever model thing we're making, we automatically should make that for it. And it should reflect and or describe that object. And we usually do that by having all or some of the data members present in the description. And we use the + operator or the concatenation operator on a string to grab those values. Here we can see using this getter, so we can get the text example right there. So it grabs that and puts it in. And the real number, we just use that. And then the number value is this, and the word Java is in this instance is plus does exist. So let's try rerunning the same version again and just hit play. And now, oh my gosh, look at this, we described the object. This is a string method describing the object. Hey, there's that same text we have right here. And then we have, oh, it reflects and assigns this, and this text example is derp because I'm using the default constructor. And here's its real number, nice little random value. And then the number value is 14 because that's how many characters are inside that sequence. And the word Java is in this test instance is false. Oh, there isn't Java in there. The other one, okay, the text example is Java. Oh, Java is actually in there, and the real number for this is 25,049 point blah, blah, blah. Hey, it's a different number because I'm using a different instance of math.random. Oh, and its number value is 4 because Java has 4 letters, and the word Java is in this instance is true because I did give it Java, because that's what this is saying right here of text.example.contains Java. So we're using right here a string method. We have a void method is called as a helper method inside both constructors. If I call this helper method before the constructor assigns that value, it'll compile just fine, but when I try and run the code, watch what happens. I have a null pointer exception at third stupid line 49. And number value, testExample.length, because I called this helper method before testExample has a word assigned to it, it crashes. So it's very important that you look at the ordering of your code and that we don't do anything that could have a reference to something, in this case text example, try to be assigned to, because any data member, until it is assigned of a value, is set to null. And that's not helpful to touch. So we don't want to make sure we do that. So again, just a quick review. We have our package which has the runner, that's the controller package. The runner itself only has one method, public static void main, and you must have it spelled exactly like this, public static void and main lowercase. It needs to have exactly one parameter, string, square brackets args, or string array args. And the way we will write all of our controllers the way we'll write all of our runners all year long will look just like this. It'll be the name of the controller, followed by app, and then assign it to be a new instance of that controller using the constructor call. And again, a method call, we always have, or a constructor call has the name of the method or the constructor, followed by the parameter sequence, ending with a semicolon. We then take that instance, app, and we call its start method. Again, so we were using the object, app, calling its internal method start, but using the dot right there. So I can call the start method on app. I can't just simply just say start, because start doesn't exist inside runner. I have to say app.start because the start method exists inside the stupid controller. We go to stupid controller, and so if we look at the flow of the execution on this, let's actually start it up that way. So we start up here with the main method. We go to stupid controller app as a new stupid controller. So we're going to go ahead, oh, stupid controller. That's inside my controller package. I know what that is. I then say equals new stupid controller. That means I'm going to go and call its constructor. So I then go over the stupid controller file, and I go to its constructor. Oh, stupid controller. That means I need to assign into text. Keyboard mashing is annoying. I need to assign to sample this.thirdStupid. Oh, I need to go to thirdStupid now and look at its default constructor. So I'm going to go over to thirdStupid.java. And inside thirdStupid's default constructor right here, oh, I'm going to say that this.textExample equals derp. So I'm going to store derp inside that data member. Then I go to helper method. Oh, so scroll down to helper method. Inside number value, I'm going to say text example and ask its length and store that in number value. Okay. Then I'm going to go to math.random and get a random number between 0 and 1 and multiply that by 1, 2, 3, 4, 5, 6 and store that into a real number. Then I'm going to go over here to text example.contains and see if it has Java. And that was derp. That doesn't have Java, so it stores false inside here. I then go back up to this. I'm done with helper method, so I leave this, which means I go back to my stupid controller and I go back to this new line. So this.secondExample is a new thirdStupid, but I pass it Java. So I go back to thirdStupid again. I go down to the constructor that takes a string parameter. I take Java, store that inside text example, and then I go back to helper method. But this time I say helper method is to be java.length, which is 4. I store that inside number value. I then get a new random number, store that in a real number, and then I say, does Java contain Java? Why, yes, it does. So I store true in this, so I go back up here to this constructor. I end the constructor right here. I've left that scope on line 27. So I go back to stupid controller. I now finish that line. I've left that line right here, so I go back up to my lovely stupid runner. So I've done that line right there. So that all happened with that one line right there at line 7. I then go to app.start. So now I go back to stupid controller and I go to the start method. Oh, start. I'm going to go system.print text. Okay, so I print the text line out. Then I go system.print sample text examples. I'm going to go to sample, which is a third stupid. So now I go to get the instruction. I'm going to do that by going to get text example. I go to third stupid, and I go to get text example. That returns the text example for this, which is derp, derp, derp. So I then go back to third stupid, and I give that derp, 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 and I print that to the console. I then go to system.println sample, and this is where it gets interesting. Instead of, if you know right here, I don't have sample I can print. What that does is it automatically goes down to the toString method. When I call a print on an object, it goes and finds its toString. If it doesn't have a toString, it gets that @ garbage. But if it does have a toString, it goes and grabs that string that is created by the toString method and prints that back up right here in this case and this case. And so it grabs and calculates those values and prints it. And that's how we get this lovely instance right here where keyboard mashing's annoying, derp, derp, derp from that get test example. And then I print out the information for my first third stupid object that doesn't have Java in it. And then I have the second toString instance right here from that second example. And so that's how a quick little example of how we can use some of the basic things and use the components of Java. So we have methods denoted right here. We have a constructor denoted right here. We have our declaration section denoted right here. Again, declaration section's always private. Constructors, usually public. Methods can be public or private depending on use. In the case of third stupid, we have a private helper method right here that's only visible inside the class. We have our public methods like our getters and setters that are visible externally. We have our constructors that are visible right here, and our data members that are always private. And so it's a quick little review of some of the things we can do to make a quick Java project and how we can see how things relate. Check out some of the other videos for some more advanced concepts. Thanks, and have a great day.